Cauchy's integral theorem, very important. The theorem states that if fz is analytic function and f dash z is continuous at each point within and on a simple closed curve C, then the closed integral over C fz dz equal to 0. What is the meaning of first the simple closed curve? If the curve does not cross itself, such kind of curve is simple closed curve, right? So this is your region R and this curve is enclosing all the points of this region, right? And which curve is not simple? Suppose the curve that crosses itself, that is not a simple closed curve, right? अब इस curve में देखो हमारे पास two regions आ रहे हैं R1, R2, right? So such kind of curve is not a simple closed curve. Now a little concept about the multiply connected region. Suppose this is a curve C1 having the orientation at this direction, the anti-clockwise direction, and this is the curve C2 with the clockwise direction, the opposite direction, right? Then the region embedded between these two curves. So वो region जो इन दोनों curves के बीच में embedded है, let this be R. Such kind of region is multiply connected region, right? So now it's very clear about the curves. So this is your simple closed curve and this is your multiple curve and this is multiply connected region, right? Okay, what is the meaning of this symbol? This symbol means it is a closed integral, which means the curve ends from where it started, right? Okay, let's move on to the proof. Let R be the region bounded by this curve C and let fz is equal to u plus iota v. Then the closed integral over C fz dz is equal to, yes, this is closed integral and fz is u plus iota v and dz is, yes, it is dx plus iota dy. Okay, so this is u dx. I'm taking the real part separate and taking imaginary part separate. So this is u dx minus v dy plus closed integral over C and this is iota v dx plus u dy. Right? Please mark this as 1. Now this is given to us that f dash z is continuous in this region, right? So the partial derivatives are also continuous in this region. So now I'm going to apply the Green's theorem over here. Just writing this, since f dash z is continuous, so the partial derivatives curly u over curly x, curly u over curly y, curly v over curly x and curly v over curly y, these are also continuous in R. Now what is the Green's theorem? Green's theorem, this is written over here. So closed integral over C m dx plus n dy is equal to double integral over R, just taking the partial derivative of this n first with respect to x minus the partial derivative of this m with respect to y. So this is curly n over curly x minus curly m over curly y dx dy. So now here in the first integral, I'm having the value of m as u and the value of n as minus v, right? So applying the Green's theorem over here, we get this to be equal to double integral over the region R. So this is minus curly v over curly x minus curly u over curly y dx dy plus iota, then double integral over R. Same, applying the Green's theorem over here also. Here m is v and n is u. So first curly n over curly x. So curly u over curly x minus curly v over curly y. So this is curly u over curly x minus curly v over curly y dx dy, right? Okay. Now because function being analytic at each point of the region, अब function analytic भी है हर point पर, right? तो हम अब यहाँ पर Cauchy-Riemann equations apply करने वाले हैं. We need this closed integral to be equal to 0. So I need to vanish these two integrals. And as fz is analytic, so I can use now the Cauchy-Riemann equations right over here. So what are the Cauchy-Riemann equations? Yes, curly u over curly x is equal to curly v over curly y, and curly u over curly y negative curly v over curly x. Now in the first integral, I'm going to apply the Cauchy-Riemann equation in the second term, that is on negative curly u over curly y. Now curly u over curly y is negative curly v over curly x. So I'm going to use over here, this becomes positive curly v over curly x. The second integral, I'm going to apply the Cauchy-Riemann equation over here. So curly u over curly x is curly v over curly y. And now these two cancel out. So the first integral, this is 0 plus 0, that is equal to 0. Hence the closed integral over C fz dz is equal to 0. Thank you.